Hello all, I welcome you all to this video lecture. This is Lakshmi, Assistant Professor in Artificial Intelligence and Data Science Department, Ramco Institute of Technology, Rajapalayam. I am here to teach singular linked list implementation using Python. So these are the table of contents. I am going to teach what is singular linked list and its basic operations, insertion, deletion, traversal, search and update in this video. So singular linked list. Singular linked list contains two buckets in the node. So one bucket is specifically for data part and other bucket is designed for address for storing the next element in the list. Here traversals can be done in one direction only since it is singular linked list. Links are from first node to second node to third node. So we can traverse from first node to last node only. Then basic operations. So we have five basic operation: insertion, deletion, traversal, search, update. So let us see basic operations in this video, and also some more operations like finding the size of the list as well as reversing the list also in this video lecture. Insertion operation. So for inserting one data into the list, we need to create a node using the same structure for that data. So then find the location where we have to insert, then change the address part in previous part as well as next part to point to the current node. So these are the steps to be followed in insertion operation. For inserting an element in the list, we have three kinds. So we can insert in the beginning, we can insert in the middle, we can insert in the end. So in the for inserting in the middle, we need to position. So to get the from the user, we need to get the index, then we have to insert at that index. So first let us see insertion at the beginning. So for this function, we need to create a node to store the data. Then we have to check whether the list is empty. Suppose if the list is empty means we can directly store the new node address in the head value, so that list will be created with the new node. If it is not empty means we need to change the head value. That is it is a pointer to point to first node in the list. So we have to change the head value. See the diagram here, this side. So here a b c d are the elements present already in the list. So e is the element to be inserted in the beginning. So initially head is pointed to a. We need to delink a from the head. So storing the E address in the head will make the head to point to E. Then we need to store the A address in the E next part. So that head will be point to E, then A, B, C, D. So these are the steps to insert at the beginning. Let us see coding. So this is the code that I have implemented for insertion at the beginning. So I have created a class called node. So in that I have defined a constructor method. So in that data and next part is initialized. Data will be initialized from the user given value. The next will be initialized as none initially. Then insert at begin function. Here for inserting a node in the list, we need a data, right? So data is passed as an argument to this function. So based on the data, I have created a node and stored it's a new node. So I'm checking whether the head is none or not none. If it is none means directly self dot head is equal to new node. I'm changing the value to head and return. If it is not empty means there are some elements already present in the list. So that new node dot next is equal to self dot head. That is I'm storing the new node address part as head value. So the Eve is pointing to A now. Now we have to change the head value as new node. So it is in the second line. So after these two steps, E will be inserted in beginning. So head will be pointing to E will be pointing to A. For search operation, we need to check whether the list is empty or not. So if the list is not empty means we can check any element. So we have to check the list with the key element to be searched. If it is present, print any successful message. If it is not present means you can print unsuccessful search message. So this is the coding for search. I'm having current variable to store the head value. Then if it while current is not equal to none, that is we have to travel up to the last element. So checking current dot data part in current value is equal to the x value given by the user is x. So if it is matches means we can return true, or else we have to simply traversing current is equal to current dot next is traversing up to the last element. So while coming out of the loop, so current becomes none, then only it will comes out of the loop. So at the time we have to return false, because the loop has traversed up to the last element, still the given element is not present in the list, so it is simply returning false as data not found. Update operation, it is almost similar to deletion from the middle position. We have to traverse through the list and point to the index specified by the user and change the data in that node. So this is the data for coding for update operation. Here current nodes equal to self dot head, we are making a head as current node, then we are maintaining a temporary variable positions equal to 0. If the position and index are matched means we can directly change the value of the first node, because if the index is 0 means if the user is asking to change the element in the first node, so we can use the current node dot data equal to val, or else we have to travel up to the node in that position. So here you see the loop. So loop and all coding is similar to deletion from the middle position. So here position plus 1 not equal to index condition will be used in deletion. For updating we can simply position not equal to index. Why? Because in deletion we have to travel up to second last element to the index, but in update we have to travel up to the current element, that is the index mentioning. So here the plus one is removed, so the same coding is mentioned here. So after the while loop we will current node will have the node at the mentioned index. So if the current node is not null means we can change the data as val, or else we can directly print index not found. Then these are the basic operations, and we can see two more additional operations. Size of the list, to print the size of the list we need a size variable initialized with a 0. If the list is not empty means we can traverse, right? So that is checked here. If size dot head, so if the head is not null means if condition will be satisfied, it will execute. So current nodes equal to self dot head, head is stored in current node. So while current node while so every time while is executing, size will be incremented, or current node will points to next element in the list. So after completion of the while node, size will be returned. So like insertion at the beginning, we have to insert at the end also. So for that we have to create a node to store the data, then find the last node, then point the make the address changes to point the last node to new node. So see the diagram, we have A, B, C, D. Then we have to insert E in the end of the list. So for that only one step is required. Just to change the address part in D to point to E. That's all. So we will see the implementation part. So insert at end function, data has to be passed as an argument to this function. So based on the data, a new node has to be created. Then we have to check head value, so whether the head is none or not none. If it is none means there is no element in the list, so we can directly insert that element to the head value. uh, Otherwise we have to traverse up to the end of the list. So in the end we have to attach the new element. So in for traversing we need a loop. So while current node dot next, so we are checking whether the next having element or address part or not. If it is none means it will come automatically out. So See here, so first time current node will have a value, so it will check a dot next. Next will have b's address, so it is not none, the loop will be executed, so up to d, while checking d dot next. D is the last element, right? So next value will have none, so it will come out of the loop, and it here we are linking the new element to this current node. So next one is insertion at the given position. Here the user will given a position. We have to attach the new node to that position. So here the same step, we have to create a node at the we have to create a node to store that data. Then we have to move to that position, then only we can able to attach to that position. So at that place, we have to make the previous node address part to point to the new node, as well as new node address part to next node. So then successfully the element will be inserted in between the list. So this is the coding for insertion at given position. So here the data and index both are the input to this function. Using the data, a new node will be created, and the current node is a temporary variable for holding a self dot head. Then position, temporary variable initialized with 0. So here why I am using position is, uh, this is the function used with the index value. So like, so for maintaining position, I have used position variable. So if the position and index are same, means that is initially the position value is 0, and the index is 0, means user is requested you to insert at the beginning, meaning so only I am calling insert at begin function. Then suppose if it is not, means user is requested to insert in somewhere else between the list. So for that we need to traverse fully throughout the list until you find that index. So I'm for that I'm using a while loop, while current node not equal to none and position plus 1 not equal to index. So if position, here why I'm using position plus 1 means, for inserting an element we don't need node at that index, we only need the node in the index previous to the mentioned index. So only I'm here position plus 1 not equal to index. For a sake, if the user is giving input as 3, means we have to traverse the list until we reach a second index. So once we reach the second index, we can directly change the address of the previous and the next element to make the correct link. So we will see in the bottom line. So in every iteration we have to increment the position as well as changing the current node. So first time it will be a, second time it will be b, likewise. So while returning from this loop, if the current node is none, means index not present. So this case, it will occur in the following case. Suppose if the use there are four elements in the list, the user wants to enter the element in 10th location, means it can't possible, right? We can't able to insert some value into the uh, list at the 10th position having a list size of 4. So it will index not found will be printed. So otherwise, a new node dot next is equal to current node dot next. So there are two address changes. First one is we have to make the new node to point to current node. So on the current node to new node, then it will be properly linked in the linked list. So like deletion from the beginning, we can delete from the end also. See the diagram here, A, B, C, D is present. We need to delete D. So here for this we need to simply do two steps. First one is iterate until you find the second last element in the list. Then assign null to the second last element null address value. Then D will be automatically delinked in the list. Then we can delete D. So this is the coding for deletion from the end. So in every function, initially I will check whether the list is empty or not, because in the empty list we can't able to delete. So in I'm checking whether the self dot head is none. If it is none means I will simply return, or else I will do the remaining processing. So storing head value in the current node, while current node dot next. So I'm checking here. I'm explaining with the example. See here, current node, initially current node is point to A, right? So A dot next means it is the address of B. Then again one next. So it is checking address part in B is null or not null. If it is null means it will come out of the loop. If it is not none means it is changing the current node value by the next value. So now the current node will point to B, then it will check address part in C. C address part is having some value, so it will change the current node. Now current node is point to C, then it will again the while loop will be executed. Here the checking address part in D is having null value as in the address part. So here loop terminates and come out of the loop. Now the current node is pointing to C, so address part in C will be replaced with none. So D will be delinked in the list. Deletion from the given position. So here I am asking the user to give the required position. In the position, the element will be removed from the list. So in this diagram, we are trying to remove C from the list. That is index 2. Here also index starts from 0. So 2 C will be removed from the list. So for this, we need to traverse up to the node in previous position in the list. So if the user is giving 2 means we need to traverse up to 1 in the list, then assign the next node of the current node in the list to previous node, so that the C will be delinked. So it is the coding part. Here I am using a temporary variable current node as well as position. Current node is for storing head value, then position is initialized with 0 because we are using index here. So initially we are checking whether the position equal to index. So position and index, if the both are same means the user is trying to remove the element from first beginning. So we can directly call the another method specifically implemented for deletion from beginning, or else we have to use while loop for traversing up to the previous element to the given index. So for I'm checking two condition, current node not equal to none and position plus 1 not equal to index. So position plus 1 not equal to index, what is representing means if I want to delete an element in index 2 means I need to travel up to 1, right? So that is meaning position plus 1 not equal to index. If these two conditions are satisfying means loop will be executed. If any one of the condition is not satisfying means it will come out of the loop. So inside the loop I will just incrementing the position by 1, and then for traversing changing current nodes equal to current node dot next. So from out of the loop I'm checking whether the current node is none or not none. If it is none means the index is not present. So it will be printed in case of the list, the number of elements in the list is 4 and the index to be removed is 10. So at the time index not present will be printed. So if it is not there means it we are changing the current node dot next value to next dot next value. Then traversal operation. So traversal is operation is for simply printing all the elements in the list from first node to last node. For this we are checking whether the list is empty or not. If it is not empty means print the data in each node. So traversal operation coding is in the right hand side. So see here I'm using a current node variable and storing the head value. So in the simple while loop I am printing the current node value and making the current node to point to next node. So in the example 1 2 3 4 5 6 will be displayed. So the one another operation is reversing the list. So see the diagram, we have initial list is 1, 7, 15, 27. The objective of this operation is to reversing entire list like 27, 15, 7 and 1. So okay, so let's see the function. So to do this we need two functions, one is previous and another one is current. Initially previous will have a value of none and current will have a value of head value. So then we need a while loop because we have to traverse from first node to last node to reverse entirely. So while current is not none, if the current having none value means it simply comes out of the loop. So while current is not none, we have to do four steps. So see the diagram here. So I will explain these four lines with this diagram. See the second diagram. So first one is the initial diagram. Second is the after updating these two lines. So next is equal to current dot next. So initially current is pointing to 1. We are making next is current dot next, that is the storing the address part in 1 to next value. Then current dot next is equal to previous. We are setting the current dot next value as previous, so none will be set to current dot next. Current is pointing to 1, right? So while setting none, the link between 1 and 7 will be cut down. Then third step, previous is equal to current. So initially previous is none, now we are making previous is 1. Then current is equal to next. Now current will be make point to 7. So okay, so first after first time of iteration, 1 will be changed as previous and 7 will be changed as current. So and 1 address will be point to none and 7 address will be point to previous, that is 7 will have a link to 1. Okay, so at every time iteration going on, the consecutive two elements will get reversed. So for the second time, current is now 7, right? So current is not none, so it will come inside. Next is equal to current dot next. So next will point to 15. So current dot next is equal to previous. So previous now having we have 1. So this will be making the changes to 15 7. So after these steps 7 and 15 will get reversed. So in the third diagram you will see these changes. So at last after this 4 times iteration afterwards, this entire list will get reversed. You can see clearly in this uh, 5 diagrams. So after every time of iteration, what are the steps is going on is displayed in the individual diagram here. So after completion of this while loop, it comes out of the loop and here we are changing head value as previous. So initially head value is pointed to 1. Now the list has been reversed, right? So 27 has to be make as a head. So in the head value 27 will be pointing to head. So thank you for listening. In the next video we will see again. So thank you.